Imagine waking up tomorrow morning and the entire universe has frozen, not slowed down, not paused for a moment, completely stopped. Every atom, every photon, every star, every heartbeat frozen in absolute stillness. The wind no longer blows, rivers no longer flow, light itself no longer travels. The sun is locked in the sky exactly where it was. Somewhere across the universe, a supernova explosion that had just begun is now trapped mid-blast. Its expanding fireball frozen forever in silence. Galaxies that were slowly drifting through the cosmic ocean have become statues in space. And somehow, you are still conscious enough to witness it. But what would that actually mean? What would the universe look like if time itself suddenly stopped? Would everything simply freeze like a paused movie frame? Or would something far stranger happen? Something that challenges the very way we understand reality itself. Because the truth is, time is not just a ticking clock hanging on the wall. Time is woven into the fabric of existence. It is tied to motion, change, energy, and even the flow of cause and effect. If time truly stopped everywhere in the universe, it wouldn't simply pause events, it would erase the possibility of events altogether. To understand what it would mean for time to suddenly stop, we first need to step back and ask a deceptively simple question. What exactly is time? For most of human history, time seemed straightforward. It felt like a universal rhythm moving steadily forward, second by second, minute by minute. Ancient civilizations measured it by the motion of the sun across the sky, the changing phases of the moon, and the slow turning of the seasons. Time appeared to be an invisible river carrying everything forward from the past, through the present, and into the future. No one questioned its flow because everything in life seemed to follow it. But the deeper scientists looked into the nature of reality, the stranger time began to appear. In the 17th century, Isaac Newton described time as something absolute. According to Newton's view, time flowed uniformly everywhere in the universe, independent of anything else. Whether you were standing on Earth or floating somewhere between distant galaxies, time ticked forward at exactly the same rate. The universe in this picture was like a giant clockwork machine, and time was the steady ticking that kept everything moving. For more than 200 years, this idea seemed perfectly reasonable. Then in the early 20th century, Albert Einstein completely reshaped our understanding of time. Einstein realized something astonishing. Time is not separate from the universe, it is part of it. In his theory of relativity, time and space are woven together into a single fabric called spacetime. This means time is not universal or constant. It can stretch, slow down, and even curve depending on speed and gravity. Near extremely massive objects such as black holes, time actually moves more slowly compared to regions farther away. If someone were standing close to a black hole while another person remained on Earth, the person near the black hole would experience time passing much more slowly. Minutes for them could equal years for someone far away. Astronauts aboard fast-moving spacecraft also experience a tiny slowing of time compared to people on Earth. This phenomenon, known as time dilation, has been confirmed by experiments using highly precise atomic clocks. These discoveries reveal something profound. Time is not a rigid background where events happen. Instead, time is deeply connected to motion, gravity, and energy. It is flexible, dynamic, and intertwined with the structure of the cosmos itself. This realization already makes the idea of time suddenly stopping far more complicated than simply pausing a clock. Because if time truly stopped, something even deeper would have to happen. Motion itself would have to vanish. Every process in the universe depends on motion through time. Electrons orbit atomic nuclei. Photons travel through space. Molecules vibrate with tiny bursts of energy. Stars burn through nuclear fusion. Planets orbit stars. Galaxies spin and drift through cosmic space. Even the beating of your heart and the firing of neurons in your brain depend on constant motion at microscopic levels. All of this motion is inseparable from time. Without time, there can be no change. Without change, nothing can move. And without motion, the universe as we know it simply cannot exist. So, if time truly stopped everywhere in the universe, everything would freeze, not metaphorically, but literally. Every particle would become motionless. Every atom would stop vibrating. Every beam of light would halt mid-journey through space. Even gravity waves traveling across the cosmos would become frozen patterns locked forever in space-time. The sun would stop emitting light because the nuclear reactions in its core would instantly cease. But even more strangely, the light that had already left the sun on its way to Earth would stop traveling. Photons currently crossing the 150 million kilometers between the Earth and Sun would simply hang motionless in space like invisible statues. And this leads to a fascinating consequence. If time stopped, no new information could move from one place to another. Light carries information, sound carries information, even physical motion carries information. Without time, information cannot travel. Which means that if time stopped, no observer could ever become aware that it had happened. Your brain works through electrical signals moving between neurons. Those signals require time to propagate. If time stopped, those signals would freeze instantly. Your thoughts would stop mid-process. A sentence forming in your mind would never reach completion. Awareness itself would vanish because consciousness requires time to unfold. From the perspective of the universe, it would be indistinguishable from absolute nothingness. Yet, there is another way to approach this thought experiment. Imagine that somehow you existed outside the frozen universe, able to observe it from a dimension where time still flowed. From this impossible vantage point, the universe would look like a colossal cosmic sculpture. Every star, every galaxy, every particle, frozen exactly where it was when time stopped. You would see Earth locked in motion around the Sun, yet never completing another orbit. Clouds would remain suspended in the sky like brushstrokes on a painting. Ocean waves would be permanently frozen mid-crash, their foam suspended like glass. Somewhere on Earth, a hummingbird would be trapped mid-flap, its wings perfectly still. A falling raindrop would remain suspended inches above the ground. A lightning bolt stretching from cloud to earth would become a frozen lightning sculpture. Across the wider cosmos, the frozen spectacle would be even more breathtaking. Spiral galaxies would remain locked in their slow cosmic dance. A pair of neutron stars about to collide would remain forever moments away from impact. A massive supernova explosion would be captured at the exact instant its shock wave began racing outward. But perhaps the most eerie sight would be the frozen paths of light. Every star in the sky would be surrounded by billions of frozen photons stretching outward like invisible thread. If time stopped right now, there would be photons halfway between distant galaxies and Earth. Photons just leaving the surface of stars and photons moments away from striking someone's eye. All of them would be frozen mid-flight, creating a cosmic web of motionless light. But this scenario reveals a deeper philosophical mystery about time. Many physicists believe that time might not actually flow the way we experience it. Instead, some interpretations of physics suggest that the past, present, and future all exist simultaneously within space-time. In this view, sometimes called the block universe theory, the universe is like a four-dimensional structure where time is simply another dimension, similar to length or width. Every moment in history, from the birth of the stars to the distant future of the cosmos, already exists as part of this structure. Our consciousness simply moves through these moments one after another, giving us the sensation that time is flowing. If this idea is correct, then the concept of time suddenly stopping may not even make sense. Time would not stop because every moment already exists. The universe would simply remain a fixed four-dimensional structure. Yet, there is another perspective that takes us even deeper into the mystery. Some physicists suspect that time may not be fundamental at all. Instead, time might emerge from something deeper, much like temperature emerges from motion of atoms. At the smallest scales of reality, in the strange realm of quantum mechanics, the equations that describe particles do not always distinguish clearly between past and future. In fact, many fundamental laws of physics work equally well whether the time moves forward or backward. This raises a haunting question. If the fundamental laws of the universe do not require time to move in one direction, why do we experience a clear arrow of time pointing from past to future? The answer appears to lie in something called entropy. Entropy is a measure of disorder in a system. The second law of thermodynamics tells us that entropy always increases over time. Ice melts into water. Eggs break but never spontaneously reassemble. Stars burn fuel and eventually fade. The increasing disorder of the universe creates the arrow of time we experience. The past has lower entropy and the future has higher entropy. But if time suddenly stopped, entropy would stop increasing. Every process that creates change, chemical reaction, star formation, galaxy collision, would halt instantly. The universe would become a perfect snapshot of itself, locked forever in a single moment. However, there is one final twist to this cosmic thought experiment. In some speculative theories of physics, time itself may be tied to quantum processes happening throughout the universe. Some researchers have proposed that time might emerge from the entanglement of quantum particles. Quantum entanglement connects particles across vast distances, linking their states in ways that defy classical intuition. If time truly emerges from these interactions, then stopping time everywhere in the universe might require stopping quantum mechanics itself. And if quantum mechanics stopped, the very structure of matter would collapse. Atoms might no longer exist in stable forms. The laws that hold particles together could dissolve. In other words, a universe without time might not simply freeze, it might cease to exist altogether. The deeper we explore this idea, the more we realize that time is not just something that measures changes, time is the very stage on which reality unfolds. Remove time, the play of the universe cannot continue. Stars cannot burn, galaxies cannot spin, life cannot grow, thoughts cannot form. The universe becomes a silent sculpture of what once was motion. And perhaps the most unsettling realization is this: if time truly stopped, no one inside the universe would ever know it happened. There would be no last thought, no final moment of realization, no awareness of the pause. Everything would simply end in a single frozen instant stretched across eternity. But until that impossible moment arrives, time continues its quiet march forward. Every heartbeat, every sunrise, every distant supernova marks another step along the endless path from the past to future. The universe is constantly changing, evolving, expanding, and transforming through the passage of time. And maybe the most mysterious question is not what would happen if time stopped. Maybe the deeper mystery is why time moved forward at all. Why does the universe allow change instead of eternal stillness? Why does the future remain unwritten while the past becomes memory? And perhaps the most mind-bending thought of all is this: if time truly defines the existence of everything we know, then what might exist beyond time itself?